Thank you for joining us today. This is the second webinar in our RTI and Early Childhood webinar series. Brooks Publishing is excited to be hosting the series, and we're glad you're watching. My name is Christina Davis, and I am the Marketing Manager for Early Childhood Books at Brooks Publishing. In today's webinar, you'll learn about the special role RTI has in improving mathematics achievement in young learners. Dr. Herb Ginsburg is with us today to present the webinar and share his expertise in the area of math instruction for young children. As a professor of psychology and education at Teachers College, Columbia University, Dr. Ginsburg teaches a course on development of mathematical thinking for early childhood teachers. His expertise is in the areas of assessment and testing, cognitive development, and elementary mathematics education. Additionally, he has developed a math curriculum entitled Big Math for Little Kids. I'll turn it over to Dr. Ginsburg now so we can hear about how RTI can be incorporated into early childhood mathematics programs.
Hello, everybody. Glad to be here, and I'm going to be talking with you today about math curriculum and instruction for young children. I don't know if you can hear the siren in the background, but this is New York City, and something's always happening. So I'm going to start with a view of what the current situation is. What are the issues that we face? And we know that one of them is early childhood math education. And then I'm going to address the issue of young children's ability to learn math. Can they really do this? And also, what do we mean by math when we talk about that? The next step is to talk about what early math education is all about. What do we want it to be? What are its components? And then, how can the RTI approach help? So, the question is, why do we need sound early math education? Obviously, we don't need bad early math education. We want to make sure it's as good as it can be. There are lots of reasons for this that you may be familiar with, but I want to make sure that I provide them as context. So first of all, our achievement in the U.S. is weak relative to other comparisons from kindergarten on. Second point is that within the U.S., SES differences in achievement begin very early, unfortunately. We see these differences beginning in preschool, and then they get worse over time. And we know that, as a recent study shows, that since 1960, the educational gap between higher and lower income people has grown a huge amount. And of course, it's not only just test scores that we're talking about. It's also attitudes, motivation, feelings. And we have data showing that after a few years of school, children don't enjoy math very much and don't like learning it. Now, obviously, that's not all children, but it is a significant part. We know that at the very outset, a lot of kids, including low-income kids, are very excited about learning math, but unfortunately, that excitement doesn't last for very long. And we know that many children need extra help in math regardless of SES. Some kids experience various kinds of math difficulties, and we certainly need to help them. So there's a lot of room for improvement in early math education. So what happens in early childhood? The first thing to recognize is that we really do very little, if any, significant math education. There are observational studies showing that a very, very small percentage of time in pre-K and K is spent on doing math. Teachers may tell you that they're doing a lot. Some of them will say, oh yes, we do shapes and we do some counting, and during snack time we do one-to-one correspondence when kids give each person a glass and so forth. Teachers do some of these things, but there's an awful lot more that they don't do and that they could do. And if you simply look at the percentage of time they spend in those activities, it's very, very limited. It's also true that many teachers don't want to teach math. I work with early childhood students at the master's level at Teachers College, and many of them will tell me, as this student did, my previous history as a poor math student makes me fear teaching math to young children in the future, that being partially my reason for choosing early childhood education. When I speak to early childhood groups, I ask them, when you went into this field, did you want to teach math? Did you see that as part of what you should be doing? And many of them say no. This is not everybody again, but it's a significant group in the population. And why is that? Part of the reason is that in education schools, some early childhood.
I'm sorry to interrupt, Herb. We're experiencing some difficulties hearing you.
Can you hear me?
I can. Thank you. Sorry.
Now you can hear me?
Yes.
So
sorry
what should I do? Just continue here?
Just continue. I'm sorry.
So where was I not heard? Where should I start?
Just talking about your students.
Okay, so my students say that, as this student did, my previous history as a poor math student makes me fear teaching math to young children in the future, that being partially my reason for choosing early childhood education. I was commenting on this and saying, well, where does this come from? One of the reasons that students feel this is that early childhood programs at colleges, at schools of education, and universities sometimes say that teaching early math is development of the field. It was the position of the field for a long time. But over the past 10 years in particular, the early childhood groups like the National Association for Education of Young Children have changed their views and now advocate intentional teaching of early math and early math curriculum. So this view needs to go away, and people need to understand that, yes, we do need to be teaching math to young kids. So there have been many responses to this situation. Parents, especially low-income parents, do want preschools to prepare kids for school. They are very worried about their kids being left out of effective schooling. The professional reports exist, like that joint position statement mentioned on this slide, and the NAEYC, National Association for Education of Young Children, and the NCTM, the National Council of Teachers of Mathematics, both agree now that there ought to be intentional math teaching starting in preschool. There have been a lot of initiatives. We have Head Start, focusing on early learning. A lot of states, 40 is probably out of date already. There's new federal funding. We have foundation initiatives. And now we also have the contribution of people in the RTI community who are interested in this. And that is why, that's one reason why we did the book, and that's the subject I want to talk to you about today. So, okay, suppose we want to do early math education. Then the one question is, are they ready? Are young children ready to learn it? What is the content of early math education? And what role can RTI play? So, we have a lot of research on kids' mathematical thinking, well, really over the past 40 years. This is not work involving achievement test scores. This is psychological research from a cognitive and developmental point of view that tries to elaborate, tries to examine what children's mathematical thinking is all about before they enter school and when they are in school. The general finding is that young kids have a pretty elaborate and surprisingly competent everyday math, and that this influences what they learn in school. So I'm going to stress three themes here about the kids. One is that their everyday math is comprehensive. Another is that it is much more complex than people often think. And the third is that it involves language and metacognition, so that learning early math is partly a language activity. It's a kind of literacy, and it also involves thinking about your own thinking. So I'm going to show you some examples on video. And I find that these communicate a lot. And I'm going to try to do this first on this screen and see if this works well. The video may be a little crude, but you get the idea, and the sound may not keep track exactly with what the kids are saying with their lip movements, but I think you're going to find these useful. So these two boys are in kindergarten, and they're playing with some blocks. And the boy on the left, Armando, had just created the structure that's behind him. And now he and the other boy, Keith Lee, want to progress further.
No, you wasn't. But I really had that circle thing. Well, but it's up to you or me, buddy.
So he said, I already had that circle thing, and that refers to the cylinder, to this roundish thing. He didn't know the word, but he has the concept. So now they're constructing. They want to place these parallel. And so, oh dear, I made a mistake. I'm going to fix it though. So he carefully places that cylinder under the board, and he finds that's too short.
Well, how about if it don't reach? I can't reach.
So how about if it don't reach?
Okay. Yeah, now I can reach it.
So notice how exact that was.
Here, money. We need 2 more.
So he's estimating.
3 more.
We need 3 more, 2 more.
There's something under there. This.
He knows about under and over.
Here, 1. We need 2 more.
So he's still estimating.
We still need 2 more. Oh, 2 more, 1 more.
You were right. 2 more.
I'll try 2 more.
He was right.
Well, maybe I see her right now. Oh, look at yesterday. Yeah.
So he said, remember yesterday we put peoples under there, we're going to make it again. So the boys' language is not perfect, but they are certainly dealing with concepts like length. They can create parallel lines in terms of setting up the structure. Their length estimation, or at least Armando's, was quite good. They are dealing with number, they are dealing with estimation. So their math is very complex and wide-ranging. Now here's an interview with a little girl at age 4, a very simple problem involving addition. 3 bears. Here are the 3 bears. Mama bear. Mama bear's yellow. Papa bear's blue. And baby bear, what color is your baby bear? Red. So she puts them in a line. They went out for what? How many bears are there all together? 3 bears. So she knows that right away. I'll go for a walk. Goldilocks got lost. They're trying to find Goldilocks. Okay? So they're out looking for Goldilocks. And you know what happened? They need 2 more bears. There are 3 bears here, right? So that's our math story. We have 3 bears. 2 more are going to come along. And we need 2 more bears. How many bears would there be altogether? And what about the other?
1, 2, 3, 4, 5.
5. So you notice that she counted imaginary somethings on the table. She was probably viewing them mentally, but she engaged her gestures in dealing with this issue and was able to solve the problem by counting on from the beginning. In other words, she didn't just go 3, 0, 4, 5. She had to count them again, partly in her mind and partly with her fingers. Sure.
Yeah.
Let's see. Here are the 2 bears that they met. Let's make sure. Now she's going to make sure. Is it really 5? You sure? Very good. And so she had a way of checking. So think of all the things she did. She was not simply abstract. She was not simply concrete. She was a mixture of the 2. She did counting. She had strategies for doing this adding. And she could check on the result as well. So this, obviously these 2 tapes are not enough, but the general literature in this area, the research literature says that the kids are already mathematicians. The question of readiness is simply not an issue. They're already doing real math. It's not written, usually, but they are dealing with real concepts like addition. And their thinking is much more complex and competent than many people realize. And language, as you saw in this video, and self-awareness is very crucial. So early math education, EME, is both possible and desirable. It can draw on these kids' abilities and their interests. It's not as if you're starting off with kids who know nothing whatsoever about early math. They have this everyday math. Learning more math need not be an imposition. They can enjoy it. It is developmentally appropriate. They can do it. And also it can involve integration with other science, technology, engineering, and math subjects. By engineering, I guess we have block building here. But it can involve integration with other subjects and with literature too. So when you think about the literature that's available to little kids, like the Three Bears, many stories are mathematical in one way or another. So we have the monkeys jumping off the bed, we have the Three Bears, we have others. So what's the role of RTI in this? Well, there's very little work that has been done so far by people in the RTI tradition, response to intervention. But in doing this kind of work in the future, we can draw upon existing curricula. Generally, the existing curricula, and there are very few of them, have been whole group, tier 1 kind of curricula, and small group. So they will talk about group activities, small group activities, but very little at the individual level, especially for kids facing severe math difficulties. So nevertheless, we can draw on these, and so we need to think about what's an appropriate math curriculum for little children. According to the recent standards and according to the research, a curriculum for little kids should be, first of all, activity-based, interesting, and playful. These are 4- and 5-year-old kids. We don't want to sit them down with drill sheets. They learn well, they learn best through activity of one kind or another. Still, the math curriculum needs to be organized. We need to do math every day for 20 to 40 minutes. In our work with preschool teachers and classrooms, we begin, of course, in October, after the kids have stopped crying every day. We begin with small amounts of math, probably maybe even 10 minutes, but very soon it becomes longer. Some of it takes place in circle time, and so that can last 10 or 15 minutes in itself. The curriculum needs to be sequenced. We know a lot about how kids develop. We know what the trajectories are in general, and so we need to sequence math activities very carefully. We need to have curricula that are comprehensive, involving number and shape and space and pattern and measurement. We should not have simply a curriculum on numeracy. Their math learning needs to go beyond number. We need to deal with both concepts and skills. We want them to understand ideas and also to memorize things and to be able to count fluently. We want it to be challenging. So we have them count to 100 starting at preschool. Actually, the count on Sesame Street counts to 100, so this is not uncommon. They can deal with terms like hexagon. Remember, these are kids who talk about dinosaurs and Tyrannosaurus rex and all these others. If they can say that, they can deal with hexagons. And very importantly, it needs to be expressive. Their work needs to require talk and explanation. We don't want the kids sitting there quietly just listening politely. They need to talk and explain why they are doing things. So an example of a curriculum like this is Big Math for Little Kids that I did with Carol Greenis and Robert Balfans, I guess about 10 years ago. And it's only one example. There are others. Doug Clemens and Julie Sarama have a curriculum as well. and called Building Blocks, and there are others. Ours was developed over 4 years with support from National Science Foundation. It's based on research, and it's for ages 4 and 5. So a program like this has several components. There are separate programs for pre-kindergarten and kindergarten. And now actually I wish we had started with the 3-year-olds as well, but now effectively it's for 4-year-olds and 5-year-olds, but there ought to be a 3-year-old version of this too. There are these 6 units, which other curricula, some other curricula agree on: numbers and shapes and patterns, measurement, operations on number, and space. We stress storybooks quite a lot. As I mentioned, there's a lot of math in stories. We know that kids like stories. We know that teachers and parents like stories. So as many storybooks as possible are desirable. Particularly useful, I think, is the flexible interview, the clinical interview of this sort that you saw me doing with the girl in the 3-bear situation. And we need planning. And so what planning looks like is this. It's, if you read across the top, this is the What Are Numbers activity. And we have weeks along the year. So we figured 32 weeks during the year, excluding all the holidays, excluding September, Thanksgiving, Christmas, and all the rest. And we have in this unit on numbers 15 activities. And the first one you see starts on week 1, goes through week 5. Others are phased in at different points, as you see. And some of them go on for the rest of the year, like number match and what we call numbers with pizzazz and lineup. These are all activities that are worth repeating and making sure that the kids really get them. And we make them, of course, harder as time goes on. And then the last activities are introduced in weeks 8 and 9. So that's what a curriculum has to look like. Whatever you may use different activities, but a sequence like this is essential. Now, many of these activities can be repurposed for tiers 2 and 3. And I'm going to give you an example of one individual learning activity on video. So this is an interviewer, Michael Preston, who works with us. And this little boy is, I believe, 4 years old. And the question is, how many bears are there altogether?
Children bears.
I got more children bears.
One more children bears?
Yes.
Well, tell me how many there are here first.
1, 2, 3, 4, 5.
And then how many with this one?
6.
6?
Mm-hmm.
How'd you know?
So you notice that he did not have to count on from the beginning. That is, to count all from the beginning, as the other girl did. He said 6 right away. Michael asks, how did you know that? Which is our key clinical interview question.
Because just one there and 6 comes after 5.
Oh, okay.
He said because 6 comes after 5.
Now how many are there? Without counting.
7.
How many? 7? Well, I added 2.
8.
8.
So again, he did not have to count on from the beginning, and he in fact corrected himself without being told the answer. So this is a very short, you could call it interview activity, teaching activity, but that's the spirit of a lot of what we do in the early mathematics programs. So in conclusion, we need a sound early math education for little kids. They are ready for it. We need to create and implement early math curricula. there really are only very few right now. There are 4 or 5 that have been created with serious research as the background. And the RTI approach can really add a lot, I think, by taking these current approaches and thinking about how they can be modified to meet the needs of kids at the different tier levels. And I think RTI can learn from the math programs about what kind of activities are needed. We don't want simple rote learning. Kids have to deal with ideas and with strategies as they proceed. And so finally, we do have these few words from Brooks, and
yes,
that is a picture of the handbook to response to intervention, edited by Virginia Bicey and Ellen Peisner-Feinberg, and we've been working with them on trying to develop, trying to modify some of the big math activities for RTI. And I thank you, and for further information, you could reach me at that address. So I'd be very glad to take any questions if you have them.
yes. So quickly before we get into the questions, I just wanted to make sure you saw that code. It's just RTIEC20, and that's a 20% discount on the handbook, which addresses all of our webinar topics and much more. And that offer is good until the end of next June. And also, I wanted to say it was just me who couldn't hear on the webinar, so I apologize for interrupting you, Dr. Ginsburg. I learned from everyone that they could hear you, so I apologize, but very wonderful presentation. Thank you. And now let me turn to the questions that we received. Let's see. Now I'm having, let me see, issues with viewing them. Okay. What are the 2 or 3 other curricula beyond your Big Math for Little Kids and Building Blocks? Can you mention a couple others that can be used?
Yes, there's the curriculum I did mention by Doug Clements, C-L-E-M-E-N-T-S, and Julie Sarama, I think that's S-A-R-A-M-A. They have the building blocks curriculum, and you can go to their website, which might be called Triad. I'm not positive. T-R-I-A-D. There's a program by Sharon Griffin. I don't remember the name exactly. It was done with Robbie Case, and it's all about early number. I'm sure if you were to Google Sharon Griffin, G-R-I-F-F-I-N, you'll be able to find it. Catherine Sophian, S-O-P-H-I-A-N, who's at Hawaii, also has an interesting number curriculum. So that's a handful, really. Maybe there are some new ones, but I think I would have heard about them.
Certainly. So if anybody, oh, here's another one. Let me see. If there is one paper on RTI for early childhood math, what would you recommend for reading?
I recommend the chapter we wrote for this book. I honestly don't know of any others for RTI with this subject matter.
And let me see. I think that to the person who asked that, if you are interested in that, I can share a couple of pages from that if you wanted to take a peek. So if anybody has any more questions, please submit them. But in the meantime, just wanted to quickly go over the rest of our webinars in the RTI and Early Childhood webinar series. On Thursday, we're going to cover assessing preschooler social, emotional, and behavioral skills. Next week, we're going to have a presentation on RTI implementation at the state level. And we'll round out the fall series with a presentation on the role of RTI in addressing the learning needs of young dual language learners. And then it's going to continue, the series is going to continue in the spring, and those topics are to be announced. Okay. Got more questions coming in for you, Dr. Ginsburg.
Okay.
Would you be able to give us an example of how Dr. Bicey and you suggested modifying one of the big math activities for a child struggling with math?
Let me try to think. The best people to ask about that are really Drs. Bicey, and I keep forgetting Ellen's last name. Fine is part of it. They are, I believe, developing some simple enumeration activities. That by enumeration I mean determining how many things there are, so that the last example of the boy figuring out how many objects there were is relevant to that. And so the methods that the tasks that they are developing, I believe, are going to involve several different ways of approaching it. So, for example, you can show the child a certain amount of things and ask how many are there altogether. You can allow the child to touch them or not. You can allow the child to move them around or not. And all of those are somewhat different from asking the child to give you a certain number of things from a larger set. But in both cases, real objects are involved, the activity is one-on-one, and you can provide different kinds of scaffolds, hints, as you go along. So the tasks are structured to do those kinds of things.
Okay. Another participant has expressed she's hesitant to have teachers juggle multiple supplemental curriculum, and wants to know if you envision some of the well-regarded preschool comprehensive curricula to be strengthened to include more math, scope, and sequence.
That's a great question. Yes, I agree that that ought to happen, and in fact, High Scope has done that. Actually, I served as an advisor to them. I should have mentioned their program already, but the latest edition of High Scope includes a lot more math activities than the earlier editions had done. So High Scope is a great example of that, and if other programs were to do that, I think that would be wonderful.
And was it flexible interviewing that you referred to earlier in the video? Is that the assessment that you did?
Yes, when I was interacting with the little girl and when Michael was interacting with the boy, we both used a flexible interview method. It's based on Piaget's clinical interview. It does not cover the kind of activities that Piaget was interested in. We're taking his method, but not necessarily the content that he was concerned about. And the essence of the method is, giving the child a problem, observing very carefully what the child does, and then when it is appropriate, asking the child to provide information about how we did it. So you say things like, oh, why did you do that? Or how did you solve that? Or so on and so forth. So that's the flexible interview method. And if I can put out an advertisement for myself, I have a book called Entering the Child's Mind, which is all about clinical interviewing, and it's published by Cambridge University Press.
Great. So do you have anything else to add, Dr. Ginsburg? We may address some more questions that come through, but right now I think we've covered them. So if you had any last few words, and then if any other questions come in before we wrap up.
No, I would in conclusion say that math education for little kids can be challenging, and it can be wonderful for kids. They can really enjoy it. And a key part of teaching ought to be from preschool onwards through graduate school. Ought to be teachers asking learners, tell me what you did. Why did you do that? How did you do it? And get them to talk about what they did, to think about it, to reflect, and to communicate to other people.
Great. Well, it looks as though from the comments, people have very much enjoyed your presentation. So I thank you for that. And on behalf of Dr. Ginsburg and all of us at Brooks, I want to thank you all for joining us today. And I hope to see you all on the next webinar.